Hello, this is Vasavi from at home. In this video, let us learn about the rational and irrational numbers. You would have already learned about the rational numbers in lower grade. Here, I'll just explain that once again. A number is irrational if it cannot be written in the form of P over Q, where P and Q are integers and Q is not equal to 0, right? So when do you call a number irrational? When you couldn't write that in the form P over Q. So here you take the P and Q as integers and your denominator can never be 0. So your Q shouldn't be 0. Any number which you can write in the form P over Q, you call it rational number. So let us take some examples for rational number. So for rational numbers, you can have all whole numbers, right? 2 over 3 or whole number. Say for instance 5. This is also a rational number because the denominator is going to be 1, right? So all this you call it a rational number. The only condition is the denominator shouldn't be 0. Okay? Fine. So if you couldn't write, if any number you couldn't write it as this in this form, P over Q form, you call it irrational. Okay? So few examples I can give you for irrational numbers are root 2. Okay? You can take root 2 or root 3, root 5, etc. And you can even say pi, the value of pi. Or you say 22 over 7, right? Pi or 22 over 7. Because when you just find the value of it using a calculator, you see that it keeps on going. The number after the decimal point doesn't terminate. Okay? It keeps recurring. It may be going just to infinity times. Okay? So these numbers are known as irrational number. I hope you understood the difference between rational numbers and irrational numbers, right? Okay. Besides this, you have a fundamental theorem of arithmetic. Here, what it says is, let P be a prime number. Remember, it is a prime number. If P divides A square, then P divides A too, A also, where A is a positive integer. If you take any prime number, and if that prime number could divide A square, then it means that that prime number can divide A also. Say for instance, let me take a prime number 2, okay? And let me take A square as 36, a number which is divisible by 2. If A square is divisible by 2, then A also is divisible by 2. What is A? A is 6, right? 6 is also divisible by 2, right? By the same prime number. That's what they say. So if P is a prime number and if you can divide A square by that P, then it means that A will also be divisible by 2. And it should be a prime number. Say for instance, if you take some other composite number, let's take P as 4, okay? And when you take A square as 6, the same 36. So here you find this composite number 4 can divide 36. It's possible. But you cannot divide. A will be 6, right? But 6 is not divisible by 4. Okay? So for composite number, this theorem doesn't work. Only for prime numbers. That's why I keep repeating prime number. For any prime number, if the prime number can divide A square, then you can conclude that the prime number can also divide A. Okay? So we will have to use this theorem in the problems sometimes. Let us do one problem here where we are going to prove that root 5 is irrational. So to prove that square root of 5 is irrational, let us assume, okay? First I'll make an assumption. Root 5 is rational, okay? So assume. So first I assume it to be rational and I prove that my assumption is wrong and hence the square root of 5 is irrational. That is what I have planned to do. So for a rational number, you know what is the rule, right? For any rational number, so here 5 is rational, right? That is what we have assumed. So your as per the theorem and your assumption, this rational number root 5 should be equal to a over b. And here the condition is where a and b are co-prime. Okay, this is the normal rule for a rational number. When it is like this, when you multiply throughout by b, you get square root of 5b is equal to a. Is that not? Therefore, root 5b is equal to a. Squaring both sides, you get 5b square is equal to a square. So from this, what do you derive? This implies 5 is a factor of, right? A square is divisible by 5, right? So you can say that this implies 5 is a factor of a square. Since you have taken a and b as co-prime numbers, prime numbers, right? Here a square is divisible by 5. So we say 5 is a factor of a square. 5 is a prime number. So I can say that 5 is, therefore 5 is also a factor of a. So you have proved till here. Understood? Maybe you can give the reason here, because a is prime. Okay, that's why we say if a square is divisible by 5, then a is also divisible by 5. Okay, now what we do, let us move to b. Okay, for that what I say is, let a be equal to 5 times some constant k. Okay, where k is a constant. So I say a is also a factor of 5. Here it is all assumptions, and then you prove that your assumption is wrong. Okay. From equation 1, what you have is 5b square is equal to a square, right? This is your equation 1. So in the place of a, I substitute this 5k. Okay. So we get 5b square is equal to, and we just now we said a is 5k. So in the place of a, I put 5k. Okay, 5k the whole square. 5b square is equal to 25k square, right? Therefore, you get b square is equal to, dividing throughout by 5, you get b square equals 5k square. 5 is a factor of b square, and hence 5 is a factor of b2, right? I continue my answer here. So what do you find from here? A and b have 5 as common factor, right? So this is contradiction, right, to the fact a and b are prime. Because if it is a prime number, then a will have only a and 1 as its factor, and b will have b and 1 as its factor. They both cannot have a common factor, right? So we can say this is contradictory to our assumption. A and b are prime. Okay. Therefore, you can also say, if you want, you can also say root 5 cannot be expressed as a over b. Okay. Hence, it is irrational. Okay. Now, let's do the next problem. Like, again, let's do the same thing. You need to prove it is irrational. So, you make an assumption it is rational. Always make opposite assumptions. Okay. Let 3 plus 2 root 5 be rational. Okay. I can say 3 plus 2 root 5 equals a over b. Again, make it, this is mandatory to say, okay, where a and b are co-prime. Don't forget to write that. Both should be prime numbers. From this, what can I derive? I can take the 3 to the other side, right? So I subtract 3 from both sides. So I get 2 root 5 equals a over b minus 3, and dividing throughout by 2, I get root 5 is equal to 1 over 2 times a by b, a over b minus 3. Here 1 over 2 a over b minus 3 is rational, right? Hence root 5 should also be rational. Only then they can be equal, right? But is root 5 rational? No, right? But we know, or we have proved, already proved, root 5 is irrational, right? So this contradicts our assumption 3 plus 2 root 5 is rational, right? Our assumption is wrong because root 5 is irrational. So 1 by 2 a over b minus 3 is rational. So this is not possible. Okay? So 3 plus 2 root 5 is irrational. Understood? We have proved it. Simple. Here, if they ask you to prove anything irrational, you make an assumption that it is rational. Just take the opposite as assumption and prove that your assumption is wrong. When your assumption is wrong, then it is naturally the opposite, right? If you have assumed it as rational number, then you can prove it is irrational by saying your assumption is wrong. Likewise, if they ask you to prove it is rational, you can take it as irrational and finally you can conclude that your assumption is wrong and hence it is rational. Okay? Hope you all understood this. Bye. Take care.